All right, let's go ahead and get started. So before we start with the obviously course content today, we had a week off. As a reminder, you should have a discussion board post on Beachboard again due right about now, so that you should be the last post on measurement strategy. And so looking at how you measure the outcome or one of the outcomes that you've chosen for the program that you're designing an evaluation for, you should have that in. If you don't have that yet, try to get it in as soon as you can. You should have gotten my feedback on all of the previous posts up to this point. So if there's any questions about that, the one with, I guess, the research hypothesis and outcome questions would have been the most recent. Just for the next couple weeks, don't forget that on 3/19, which would be a week from today's class, you have your next discussion post, and then 2 weeks from today on 3/26, your literature reviews are going to be due. So those and an additional discussion post, post number 7, will both be due on the 26th. And then we have a break for spring break the week of April 2nd. So before we jump into the content, I want to just kind of pause there, see if anyone has questions about the feedback so far, specifically the lit review assignment, the lit review feedback you've got in terms of the discussion post. If there's any questions about that, let's tackle those now, since we got a little bit of time before we jump into the lecture. All right, I'm not seeing any questions coming in. So if there are questions, you can always email me as well. If not, I'll stick around at the end too, and you can ask me your kind of specific questions after the lecture is over. But we will jump into validity and research design. And really, this is where we're going to get into the idea of understanding, right, that we've talked about validity before, and we've talked about validity in the context of measurement and measurement validity. Remember, we talked about reliability and validity and precision as we talked about measurement broadly. And validity is not limited necessarily to measurement. Validity is part of research, and something being valid has a lot to do with the fact that, right, not just your measurement, but your design. Really, you're thinking about the conclusions that you were drawing from the data you've collected and the analysis you've done, and asking yourself whether or not you put any faith and legitimacy into the findings that you have as a result of whatever process got you to that conclusion. And this is really what we're talking about in terms of validity with research design, which is the approximate truth of the inference. How good are your conclusions about cause and effect? Right. So if I were to ask a question, for example, and say, what color is the sky? And you were to say, well, I'm sitting here inside, I think the sky is blue. That's the most obvious answer, right? How comfortable do you feel in that you are correct and that you've got the right information, right? Well, if you didn't go outside and look, right, that's probably not the most valid way of getting to that conclusion. And that's kind of what validity has to do with is, well, how did you get to that point? What was the process by which you collected data, analyzed, et cetera, to come to your final conclusion, right? If you were to say, well, right, I've seen the sky a whole lot, odds are more often than not, it is blue more than any other color, and therefore I came to my conclusion, maybe that's a more valid process, right? A better process is, well, I went outside, I looked at the sky, I had a friend go outside, they also looked at the sky, I called somebody else I knew across town, they went outside and looked at the sky, all three of us reported back and said, right now it's currently blue. Right? So the conclusion is that it was blue. Right? That might be the most valid way of getting to that decision. Right? Could be the fact that, well, I'm inside, probabilistically, I think it's going to be blue more often than not. So I said blue, even though it's sunset, and right now it's actually orangish, yellowish, reddish, and I didn't go outside and look, right? So I may be invalid in my inference that I'm making, right? Because I didn't collect the right data, or the data that I am relying on is, and well, my old ideas about what the color of the sky is, all of those things led me to come up with a less valid inference. Right? And that's really what we're talking about, which is if we're going to design research, we need to be able to come up with a strategy to collect data, to compare, right? Use that information to conclude something, and know whether or not the thing that we concluded, the conclusion that my program resulted in the following change in outcomes, right? That conclusion, whether or not we believe it, right? And so you might have like a nutrition program, for example, where, I asked everybody who was in my program whether they felt like they were healthier than when they started. A bunch of them said yes, right? And therefore my program leads to people being, to losing weight, right? Well, you didn't really ask about losing weight. You asked about whether they feel healthier. Right? Perceptions of how healthy they are not necessarily the same as actual health, right? So, you could say my program leads to people feeling like they're healthier. That may be a better conclusion from that same kind of process, right? But to say that it led to lower weight loss is not true or not a valid conclusion because you didn't necessarily collect data on weight, right? You didn't actually collect data from before the program started to see if they lost weight. You just happen to know what their weight is right now, and you're saying it's less. Questions about that? Does that make sense in terms of just validity broadly and what it means? It's really, the idea of correctness of a statement. You think about politics these days, and we talk a lot about fake news and bias and things like that. Right? Validity is the idea of, right, if the news is fake, right? Well, how did they get to their conclusion? And do I trust it? And is whatever they're saying believable and trusted because of the process they went to? Did they collect information? Did they go do primary source news reporting? Did they assess it and analyze and check was the information that they got good, right, before they reported it? Or was it something I found on Facebook where someone reposted a picture from some unknown source and therefore, right, it's kind of an invalid conclusion? Right. Internal validity, right? This is because validity can mean a lot of different things. What you're going to see here is there's really 4 different types of validity that we're going to talk about. One of which you've already learned from our discussion on measurement, right? But knowing the differences, right? So internal validity, this is the validity of inference about whether, right, covariation between A and B reflect a causal relationship. Right? What that means basically is when you do research and you're looking at a research design, at the very end of your analysis, you're going to say, right, does the change in exposure to my program, does participating result in outcome that I care about going up or down like we'd want it to be, right? Is that relationship between those things, right, the true relationship, right? Does it make a significant difference, right, in this instance, right? Maybe my program doesn't work in all instances, but for the one that I've collected data for and analyzed at this point in time, is it true, right? So we're concerned with causal reasoning, meaning if I'm going to say the program led to this change, right, we need to know that, right, nothing else possibly could have led to that change. Did we have a research design that ruled out other factors that presumably could have had an impact, right? If I say that my nutrition program leads to all of these participants' weight loss, and it just so happens that all of the people in my program also were participating in 4 different weight loss programs on the side, which I didn't know about and I didn't try to measure and control for, I may ultimately conclude, well, my program led to this change, and I may be wrong about that relationship because other things could have done it. External validity, right? Think about this is, right, we sometimes call it generalizability, right? We're looking at applying the research results, right? External validity is not really something that broadly we can think of as, right, well, you either have it or you don't, right? Most people will tell you external validity. So an example of this is if I take a program that is based in downtown Long Beach, for example, right? I think one of, I want to say potentially, one of the programs that one of y'all is looking at is focused on bike paths, building, right, more bike infrastructure in the city of Long Beach, right? If we were to look at that program and do an evaluation and say, well, this program, right, as we've implemented it, led to an increase in bike ridership in the city, right? That may be true for the city of Long Beach. If we were to say, hey, if you want to try to improve how many people ride bikes to work in other cities, take our program and replicate it there because we know it works, right? External validity has to do with the idea that, well, do the results that I found in Long Beach generalize the same, right, if I were to try to apply them to someplace else, right? For example, if you take a, let's say you take a, some of, I think the programs, there's a couple people looking at First 5 LA, for example. You're looking particularly at Los Angeles, low income families, a lot of times underrepresented minority populations. If you were to have, let's say, all Hispanic participants in your research, right, and you were to say, look, First 5 home visit programs lead to an improvement in health outcomes, right, your conclusion may be true that your program in this case leads to those health outcomes for your participants. But external validity has to do with, well, can we generalize the results of that research to another group, right? If I were to take it to New York City and say, is it very likely that our First 5 program here, First 5 NYC, whatever it is, will have the same impact, right? How far likely does it, or how far off does it seem that that's potentially true based off of the way your research was done, right? External validity is not as important as internal validity for you as the researcher, right? Because the important thing is that you get, right, your research done correctly, right? If you don't have internal validity, nothing else matters because it's bad research. External validity is something that is nice, but is not necessarily essential, right? Let's say First 5 New York City happens to have a predominantly African-American population base, not Hispanic, right? Can you necessarily say the same findings are going to hold true from First 5 LA's evaluation as they would in New York City? It's possible because it's a similar program and it's a similar urban population and it is underrepresented minority populations. But our research really only included Hispanic, Latino, Chicano populations, not African American, and therefore we don't necessarily know if the results are going to hold. Right? The only true way of finding out if that result has external validity is for someone to do the evaluation in New York City, redo that same type of research, and look at the question again and say, like, does the same conclusion hold here as it did in the LA example? Right? So that's where you get down to this point, which is a lot of people will talk about external validity. How well can we generalize the results of this finding? And this is true because as public administrators, a lot of times we're going to look at research that isn't exactly the same as what we're trying to do here, but we're going to use that research to shape our decisions and inform us, right? Especially if someone finds that something works, we're likely going to look at that in a situation and say, yes, it seems like it's a close enough situation to what we're dealing with here. I potentially am very interested in trying to have our program work better. So we're going to believe that that is going to hold in our same situation. Not everybody always has the time of doing, right, the literature review, the meta-analysis, right, actually redoing the research in our context to see whether or not it actually, can be replicated here in the same way. Right? That is true external validity, is taking the same research, redoing it here and saying, hey, we found the same thing in First 5 New York City, that our program, even amongst predominantly all African-American population in New York instead of in California, has the same impact, or at least has the same positive effect, right? Maybe it's a greater impact or a lesser impact, but it is a positive impact overall. Then we know that the results do generalize elsewhere. Right? If we were to take the same thing and say, okay, well, let's take it to Omaha, Nebraska, it's more rural, it's lesser populated, it's less dense, right? It might be a predominantly sort of a Caucasian population. It may not generalize there because it's different in the first two examples than it is in the third. And we really wouldn't know unless somebody in Omaha decides to then redo the research again and tell us whether it continues to hold or not. Does that make sense, the difference between those two? Are there any questions about internal versus external? When they would apply or why they matter? If you have questions, either put them in the chat or just jump on with your mic. I don't see any. So, right. I mean, the important thing is that this is always, right, a first priority. Internal validity, right? If you don't have it, right? You can't trust anything that comes from your research, right? The research is designed so poorly that any conclusion that you're going to make presumably is invalid or so not you can't put any faith in it that right you just really didn't you just kind of wasted your time. External validity, it matters. It's not our first order of concern. It is something that fundamentally has good reasons to think about, right? But it is not always the concern of the researcher because I'm concerned with my setting and context and population and doing research right here, right? Whether or not it applies to somebody else the same is their problem, right? If you're concerned with external validity in your research, let's say I want to be able to generalize about let's say we're doing a research on Cal State University Long Beach students, and we want to be able to know whether or not the population of all students at Cal State Long Beach supports a tuition increase for next year or not, right? Or how much do they oppose it, right? I'm very much concerned in this case, both with internal validity, because I want my research to be good, right? But I'm also concerned with external validity because I'm going to have to take a sample. I'm not going to be able to ask everybody. And I need to be very concerned that the conclusions I have are able to be extrapolated and generalized up to the entire student population so that I can say with certainty whether or not there's support there. Right? If I stand outside the library and I ask the first 50 undergrads who come out the door on a Tuesday and I say, well, 85% of them are fine with the tuition increase, then the entire student body also agrees 85% with the tuition increase, right? That is not you basically, those 50 people, you may have the correct internal validity conclusion about, well, they 85%, don't support it. But you can't generalize that same way because, well, you didn't ask. It's not random. So you don't know if you didn't get any graduate students in there. You don't know because those people were at the library whether or not they're different from the rest of the student population. They're on campus during a Tuesday, and so they fundamentally might be people who are either living off of loans and therefore don't have jobs, and so they are on campus more frequently and have a different perspective than people who have to work to pay their own tuition, something like that. Right. So being able to generalize and say, well, 85% of the population doesn't support it, or maybe 85% does support it. You want to be certain that you are claiming the right thing about that larger population. And that's when external validity becomes important to you. And you'll see when we talk about sampling next week, we're going to talk about threats to external validity and sampling, how the decision of how you sample makes a difference on whether or not you can generalize to a broader population. But that always becomes sort of a secondary concern depending on your research question or context. Right. The next one, this idea of construct validity. This basically is the validity we talked about when we talked about measurement, and we discussed reliability and validity from what would have been, I guess, last week or 2 weeks ago. Right. So the idea that constructs, meaning, remember we had the little graph where we said there was a concept, right? And then somewhere beneath your concept is a measure, right? And really what the key is to measure, you need to find that you have captured this relationship between the concept and the measure. How well you reflect that concept with your measurement strategy is your construct validity, right? So, this is the degree to which the instrument or the measurement that you've created claims to measure, or the extent to which it measures what you claim to be measuring. So if I'm measuring post-traumatic stress, does the measurement tool that I'm using capture post-traumatic stress correctly? Is this relationship between the measure and the concept valid? That's your construct validity. And then this last one, statistical conclusion validity. People take a lot of classes in statistics because there is a mathematically and technically correct way of doing statistics where you will get an answer that is valid, and there are other ways of doing statistics wrong where you will come to the wrong conclusion, right? The same way, if you don't know how to add and you say 2 plus 2 is 5, right? You got to the wrong answer because of a technical error, not because 2 plus 2 is actually 4. Right? This is really the basis of statistical conclusion validity. Is if you screw up the math, you don't have statistical conclusion validity. Your analysis itself is flawed, right? There are errors in your analysis, right? And there's reason to think you screwed up the statistics. And therefore, if you have external validity and your measurement is good and you have internal validity because your research design is good, all those things don't matter because you added stuff wrong at the end. And that becomes equally as important because, for better or for worse, it's a problem and it makes you look stupid because you screwed up, which is never great. Right? But at least if the other three things are correct, hopefully you can go catch it and fix and correct the statistical analysis at the end and figure out what you did wrong because you collected data well, you measured things correctly, right? You got everything up to that point done properly, so that all you have to do is go back and redo your math, so to speak. Questions about any of those four things before we move forward? So the four different types of validity broadly, any of those type of things that people might have a question about. They're good devices and tools to think about, just so as you think about research design, the things that you need to be concerned with, they're really the kind of four major points where you might end up incurring problems with your research, right, or introducing error, either because of your measurement, because of your analysis technique, because of your sampling technique, or because of your research design. Those four things tend to be ones that you need to really keep tabs on and make sure you've done your best to address all of them. If there are no questions about that, I'm going to move on to what we call threats to internal validity, right? So threats to statistical construct validity, we're not going to talk much about at all. You obviously will have to take statistics classes to learn that and make sure you do that correctly. We've already talked about measurement, so we've covered that one. External validity or generalizability is going to be something that has to do with sampling, which we're going to talk about in a week, right? Right now, threats to internal validity are talking about, right, if we're looking at internal validity, these are a list of different things that you could think about, right? And think of each one of these as a framework by which you can use to try to assess whether there are issues that might affect your research design. Right? We're going to talk about research design and how you make better or worse research designs. And if it's better, it becomes better because it does a good job at being able to mitigate or eliminate these types of threats to internal validity from being an issue. Right? So this idea that there's priorities and trade-offs, meaning you're never going to be able to address all of these. There are always going to be possibly multiple at any one time affecting your research, right? But you're going to have to figure out a research design that addresses some, right, while not addressing others. And these help you think about which ones are more or less of a problem and make then decisions about your research that'll help you address them. Right? So, right, well, what do we want to say that these are, right? Internal validity itself, or threats to internal validity, is basically this. Right? Reasons to believe that the relationship between A and B is not causal. Meaning, right, this is really key here, which is if we're going to say that our, let's say, nutrition program is a program that is going to reduce obesity or lead to weight loss, right? What other things exist that could lead to a reduction in obesity or a loss of weight amongst participants in my program that aren't the responsibility or fault of my program, right? If the causal relationship is not between my program and the weight loss, what else could have potentially resulted in the weight loss or the loss or the reduction in obesity that isn't my program, right? This idea of pattern matching, right? So this, we'll think about this a little bit where, right, if you're familiar with, if you're a visual person like me, right, you have a graph, right? This is time, right? And this is weight, right? This is, let's say, the average weight of a participant, right? So we take everybody in our program, we ask them how much they weigh, right? We add them all up, we divide by how many participants are, and then we put a dot, right? And we say this is, right, week 1, this is week 2, this is week 3, this is week 4, right? And we see this, right? And then we see this, and then we see, right, this, right? Here's our sort of general trend here, right? We go from here to here to here to here, right? And then we haven't collected any more different data from that point. right? For starters, what we see is right, between here and here, right, this is weight loss. So we obviously are seeing right, a reduction in weight. Right. So when we're thinking about threats to internal validity, we're talking about pattern matching. Right. Remember, it's got to be the same outcome. So if something right, could have led to weight going up, right, not going down, it's not a threat to internal validity because, well, we're trying to prove through our research that weight went down because of our program. Right. If something else is pushing the weight up, right, then what in actuality could have happened is that this, right, is right. We'll call this the gain, right. So we actually should have seen right their weights fall to this level, but there was something that was actually causing their weights to go up, right, working against us. But if we still see this drop in overall weight amongst participants, right, that's not a threat. It does have an impact on us potentially underestimating just how effective our program is. But if we find that our program led to right, weight loss, then right, it's only going to help us even further if we address that issue because we might have seen even a bigger gain. Right. The purpose of pattern matching is the idea of this, right, which is right. You'll see here in week 2, right, and in week 1, right, what happened to their weight? Didn't change at all, right? From the first week to the second week, we didn't start to see anything happen. It didn't go down, right? Between this point, right, week 2, and this point, week 3, right, we start to see a reduction, and then week 4, we start to see a reduction. If something is a threat to internal validity, right, it has to be something that would also bring right, their weight loss down. It also, for pattern matching purposes, what that means is it also needs to be something that would have resulted in weight loss going down between weeks 2 and 4, right? Because nothing happened between weeks, we'll call this 0 and 2, right? Because nothing happened here, right? Well, we can say that whatever is going to be a threat should have only kicked in at week 2 because this is the pattern we see. Right. So one of the issues, right, why this becomes important is if you think about this idea that let's say we do time and we'll do weight again. If we look at week 1 and week 2 only, right, what happens? Right, week 1, week 2, this is time. And we say, well, the average weight is here. And then the next week, our average weight is here. Right, so we have this trend going on between weeks 1 and weeks 2. Right, because we collected less data. We only captured data right when they started and right at the end. All we know is that their weight went down a little bit. Right, what we don't know is, right, maybe after week 2 it stayed the same. Right, maybe after week 2 it went back up. Right, maybe at week 0 it was already going down. And so while during this period, right, we attributed this right, loss of weight to us, if we'd have collected a little more information, we would have seen what was going down at the same rate anyway. That's probably not good for us because how do we prove that we didn't have, right, how do we know we had an impact during this period of time when in actuality, it looks like that would have been the general course of direction no matter what. Right. So when we think of this pattern matching idea, what we're talking about is, well, we want weight to go down. Right. We also want weight to go down at the time period where the program is starting and having the impact that we believe it's having. Right. So threats are things that can lead to that reduction, but they're also the same things that would lead to reduction during that same period of time. And we look at, well, if I collect data back, right, 2 weeks earlier before our program starts, right, I can see if their weight is changing over time before I decide to start my program and see if it has a change on their actual weight after I can see what that preliminary trend is, right? So as we're trying to prove the impact of our program, we're also trying to create a pattern that, right, this valid logic shows, right, well, because we collected their data, our program started here, they lost weight, right, our program ended, 2 weeks later, they started to gain weight again, and then we put them back in our program, they lost weight a second time. Right? It's really hard to then argue any threat to internal validity is the other cause of the weight loss, when the pattern is so obvious that right when we started, right when we ended, and they went back up, and then right when we started again, it went back down, because any threat now has to be, right, something that would result in weight loss at those same exact same points of time, right? This is important. You can't deal with all threats simultaneously. There might be multiple in some of your instances. You're not going to be able to address every one of them. Right? Your best bet is to try to deal with the biggest ones and work through the smaller ones to see how many else you might be able to address, and make sure that you've done your best to head off some of the worst of the offenders. Questions about that before I talk about what they are, and hopefully I'll explain each of the different threats and give you an example. But if there's any at least initial questions before we start that, go ahead and ask them now. All right, I don't see any questions, so we'll go ahead and get started. So the first one, ambiguous temporal precedence. Right? This seems basic, but it is something that in government we deal with, which is the idea that, right, we need to have clarity. Remember, we talked about how you determine cause and effect. Right? We need to know that X, right, leads to Y. What that means is, right, let's say we have a government program that we are running, right, and this is time again, right, and we'll say this is, we'll call this January, February, March, April, May, June, July, August, September, October, November, December, right? This is our year, right? This is the outcome we're concerned about. If we have this calendar system and we know, right, let's take the trash example, right, where they had, right, the trash was doing something like this, right, and they had, right, something like this, and then we said, okay, August 1st, we implement the new government program, right, and what we see is that trash, right, does something like this for the rest of the time, right? We can say, well, we started the program, right, clearly right here. The pattern shows that there's a reduction in overall trash production as a result of when our program kicks in, right? If we have the same thing, right, January, December, right, our outcome of interest, right, and let's say trash does something like this, right, and we say, well, the program was supposed to start in August, but we actually took about a month to hire everybody, and then we actually had another month where we had budget hearings and meetings, and then we got our funding, and so we started doing marketing and advertising, and then we started actually enforcing our services, right, through November, right? What happens during this whole period of time if you're trying to prove that there is an impact of your program? It gets very muddied and very difficult because, well, right here we started to see a drop in the first place. During this period of time, we see a lot of fluctuation, right, between things. We start to see some drop off here, right? But who knows, because, well, there's this already trend. There's this trend that's going on. This trend right here happened before you started. Right? During this whole period, everybody's confused about what day your program actually started working, right? And whether or not, well, maybe we announced the project right here, right? But we didn't actually start doing anything until, right, we said August, September, right? The question is, did this, right, reduction in trash that happened right here, was that because of our program, because we announced beforehand, or, right, was something else the case because, well, we actually started afterwards and the trash reduction started before us, and actually something happened right here that we're not thinking about that led to basically this whole decline that wasn't our program, because ours was this kind of muddied window of time. That is ultimately what we're concerned about, is in order to say something X causes Y, X has to be certainly started and implemented and begin before Y starts to happen. Right? Seems obvious, but at times, right, there are situations where, right, well, the trend is already starting like this, and then we started our program, and it took us 9 months to roll the whole thing out, and then we're going to say we had this big impact, even though everybody knows it was 7 months of government time before we actually even started providing any services in the first place, because we had to post our jobs and hire people, get our policies written, develop a strategic plan, right? Stakeholder meetings, blah, 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 all this other junk. Right? So that's the first threat. If you can't say, I know for a fact that all of this occurred, right? You signed up for our program, you were in our weight loss program for 4 months, the program ended, and then we can say that your weight went down, right? We can say that for sure this happened before that, right? But if your weight starts to be dropping before you even sign up because you really want to get in shape and it's a new year, and so you started exercising and you started going to the gym and you joined our program to also help you, right? Now we start to money the time period situation, right? Questions about temporal precedence? Hopefully that one's at least a little easier. Right. Selection bias. This is generally, of all of the different threats to internal validity, the most commonly talked about one, the hardest one to address, the one that will typically be the biggest issue for all research in general. Right? Differences between, right, systematic differences, right, between the groups are what lead to the observed effect. Right? Think about this. If I have again, nutrition program, right, where people have to sign up to my program to get the benefits, right? I may do my research and compare the people in my program to other students on campus to say, well, look, our program led to weight loss that did not occur to these other students who weren't in our program, right? Because the people in my program got to sign themselves up, a question that will forever remain unanswered is, maybe the people who are most dedicated, committed, interested, already starting on a path towards getting into shape are the ones who signed up. And I'm comparing to people who had no interest in signing up, didn't care about losing weight, and of course weren't going to shed any pounds because that wasn't a goal of theirs in the first place. Right? If I say, look, we had this reduction in weight compared to average, right? I can't say that with validity because the group I'm comparing to, right, there's a selection bias problem. They didn't sign up, right? Even if I don't compare to this other group and I just pick people who signed up and I say, look, they lost weight, right? You're always going to forever have to deal with the issue of, well, these people wanted to lose weight. That's why they signed up. And so therefore it was their motivation, not your program, that result in the weight loss, right? It works in most cases. I have a prison education program that's meant to help people get a job and keep them out of jail. And guess what happens? It's voluntary, and the people who sign up to get their degree are the ones who care most about getting an education. They're the ones who care most about staying out of jail. They're the ones who care most about getting a better job. And not surprisingly, when they get out, they get a better job and they stay out of jail because the other people who didn't sign up didn't care, right? Or because they were motivated in the first place, right? They kept themselves out of jail whether I gave them a program or not, right? That is the selection bias issue. It's difficult to overcome, right? We do our best with control groups to try to show, here's what people who are like these folks look like and what would have happened to them if we didn't have, if they basically were similar people who didn't sign up. There's a thing called propensity score matching that you'll see, or PSM. This happens. Sometimes they do it a lot with like the prisoner programs, and what you'll see is they'll take, right, this is a participant, and they'll do something where they'll say, I need to know their age and their race and their education level, right, and the years of work experience. And I want to know the type of crime that they had. I want to know how long they were in jail. And I want to know, were they in a gang? Right, so on and so forth. Let's say we pick 20 characteristics here to find a person. Right. I want right, we'll call this a comparison person. Right. Because the participant is someone who signed up for the program and therefore is a threat for selection bias, right? I need to find someone who's a similar age and a similar race similar education, similar work experience years, right? Committed a similar crime, right? I don't remember what long was for, right? Wasn't for in a gang, right? How long they were in jail, etc. And then basically, if I can match those two people up on like 20 different characteristics, I can say, well, generally, right, these seem to be two comparable people, and one's in our program and one is not. And so because we've matched one-to-one on all these characteristics, right, the propensity score is a number that we've created from all those variables to say, right, this person's a 52 and this person's a 54. They're very similar to one another. Right? Therefore, they're alike enough that selection bias isn't an issue. That's one way of doing it. Control groups, which we'll talk about in a bit, is another way where we just find another bunch of people who are similar in many ways as a whole. Right? It's not a one-to-one match, but it is sort of a broad cross-section. Right? These are Cal State Long Beach students in a nutrition program. These are Cal State Long Beach students who are similar grades, similar majors. They happen to be other people who do outdoor activities and therefore have an interest in fitness. Something like that, compare it that way. The best way, right, and we'll talk about random assignment. The way most places address selection bias is if I have 50 people who want to be in my program, I give half of them to the program and I give half of them not, because they all signed up, but half get to wait. And therefore, we don't have a selection bias issue because all 50 signed up. Right? The traditional example you'll think of is clinical drug trials, right? 50 people have a condition. They all have the same disease. They all want treatment. So there's no difference amongst them. Half get a placebo and half don't, right? Randomly. And we see what happens to those who took the placebo versus those who didn't. And now we believe that selection bias isn't an issue because they all have the same condition. They all wanted to participate. We just so happened to put them in a perspective where we had control over it. That doesn't work in most government settings because we don't usually get to tell people no. We can't turn people away and say, great, you're interested in getting welfare benefits, perfect, but we're also doing some research right now. So since you signed up, we're going to just not give them to you for about 6 months because we're very interested in doing this study. It doesn't work that way. So we're always inherently going to be stuck in the situation where selection bias is probably going to be an issue, right? But dealing with research that has some selection bias is still better than not doing any research at all and just hoping that our program works based off of the idea that, well, we feel like it helps people, right? So if there's ways to minimize selection bias, if there's ways to address it, we do our best. One example sometimes will be if you have a wait list, and so some programs can't help everybody at one time, or people sign up, let's say it's a cohort-based system, and those people who sign up right now have to wait 5 weeks before the next round of classes start. Following those people for that 5-week period who signed up are very much like people in the program. You can compare those folks to the people in the program right now, right, because they should be very similar to one another. History, right? This is an easy one. Something else, right, that occurred at the same time is the reason for the change, right? If we go back to this, again, we think about, right, we have time. We're concerned with time, right? Let's just say we have a Cal State, we see a trend. Let's say this is homelessness in, right, we'll call the city of Long Beach, right? And homelessness looks like this, right? And then we start to see this, right? So we say, well, look, we started this program in June, right? This is, we'll say this is June 18. This is June 19, right? 1 year later, our program obviously led to this big reduction in homelessness, right? If at the same time, right, state of California, right, starts dumping a whole lot of money into grants and tackling homelessness across the United States, or sorry, not the United States, but in California, right? And they basically kick in their funding from here on. Very big history threat. It's very difficult to say our City of Long Beach program that ran during this period of time led to the same reduction. It just happens to coincide, unfortunately, with this same period that the state of California, right, happened to cease what they're doing. right? This is where pattern matching comes in, because let's say the state of California continues their program into the future, right? We did a 1-year pilot program that ends, right? We start to see homelessness do this again, right? Starts to trail back up instead of continuing this direction. Now we have a pattern matching situation where we can say, well, it's probably not the state of California. Maybe California helped us bring it down, right? But as soon as our spending and program and grant money ran out, right, it starts to slowly work its way back up over time, right? So even though this period of time was initially, right, what we would call a history threat, right, because we did this pattern matching and added this extra second piece, we can now, say that it's probably not a history threat that's the problem, right? Remember, right, we're going to talk about X's and O's, right? Each one of these data points, right, this is where we talk about measurement. Let's say this is the number of homeless persons per month, right, during a period of time, right? We've collected, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right, 11 months worth of data. If, let's see if I can pull this off without deleting my whole thing, right? If we were to have only collected this data, right? Let's say even as simple as keeping points, right, 3. And we just happen to say, okay, well, we're going to collect data on homelessness in the city for, right, 1, 2, 3, 4, 5 months, right? And we decided to do it for a 1-year period during the extent of our grant from July 18 or June 18 to, this should be June 19, right? Are we now able to say, well, that our program worked in spite of the fact California was running a similar initiative at the same time? Does anybody feel comfortable with that conclusion and believing with 100% certainty our program had the impact, not the state of California? Put yes or no in the chat box. Let's see. The fact that we had, I lost it. The fact that we added, right, those extra 3 or 4 months worth of data on the beginning of the study and the extra 3 or 4 months worth of data at the end of the study were the only reason that we are able to say that the history threat, which is the state of California budget initiative, right, that did take place, isn't a threat, is because we had that kind of 3 extra months of data on both sides of the year period that we were doing the research, right? That is a research design decision where the fact that we decided to get 6 extra months of data is the thing that addressed that history threat. Because when we only had that kind of 6-month window or the 6 data point window during that 1-year time, there's no way we could have said, well, California state initiative and ours ran at the exact same period, right? This pattern happened and we don't know what happened before or afterwards, right? History threat is a very real threat, and it makes it so that your conclusion is really not valid. By simply getting a little bit more data and planning a little bit better from the beginning, we're able to say, California happened at the same 1-year period, but look what was going on before and afterwards. It wasn't California, it was our program, right? That is how we deal with that history threat. And this is where, right, the whole research design process matters, because how you collect data, where, how frequently, etc., is what helps you address these issues. Right. Any questions about those first 3? Right. So another example is this idea of maturation. Right. Maturation, if you think of the word maturity, is the idea that stuff over time, regardless of what you do, is going to happen to change. Right. no matter what, just because of time. So if you think about the most obvious example is health, right? As you get older, with time, you're going to be in less good health as you reach a certain age, right? There's really nothing you can do to stop that. It's going to occur over time, right? If you think about children, a lot of times people will have programs and initiatives that try to help improve cognitive development, academic preparation, getting kids ready for school, right? If a child is born 1 year old, 2 years old, 3 years old, 4 years old, 5 years old, right, and we were to plot out what does their cognitive development look like, if you do nothing whatsoever, what happens to a child's brain, right? Something like this, right? At a certain point, we become adults and we stop learning as much, and our brains don't develop any further, right? As a child, no matter what happens, right, because you are born, a maturation process occurs, and you will become more developed cognitively with time, no matter what happens, right? So if you have a program that is designed to intervene at somebody's 3 years old and 4 year old, right, and say we're trying to help prepare them for school, right, what do you notice that happens between these 2 points? There is an increase that happens between point age 3 and age 4. Whether or not you do anything at all, it goes up, right? The fact that that happens means that there's a maturation threat that you have to deal with. Because if you just basically collected data here and here and said, look, right, their development was, I don't know, we'll say a 20, and then their development was a 25. And so our program led to a 0.5, a +5 cognitive development scale increase. Right? That's an invalid conclusion because, well, they probably were going to gain roughly 5 points of cognitive development on the scale, whether you did anything or not, right? What you have to be able to show is that, well, look, right, this is a +10, this is a +5. We took a whole bunch of children, and on average, everybody developed at this level, right? Our program intervened at age 3, and what did we see? Right, we see this increase that happens instead of this increase. And therefore, even though maturation was a threat, we have a sharper increase in cognitive development, which means we're helping them develop cognitively faster than what would have happened if we did nothing. Right? So what would have been the threat, because you only collected data here, right? Because you added, we'll call this a control group, you took another bunch of kids the same age who are not participating in your program and said, well, what is their cognitive development? Right? They went from 20 to 25. Right? Our kids went from 20 to 30. Right? This is our treatment group. Right? This is our control group. Now maturation threat is not a threat for my research because I've done my due diligence and got data from 2 people, right, 2 groups of kids, similar age brackets, right, track them for the same period of time and know how fast they would have developed if we were not participating in our program. That make sense? Questions about that? Maturation can be a decrease. Doesn't necessarily have to be an increase. People, age, if you're looking at health, right, there's going to be a slow decline in health over time that's going to happen. Right? You might actually be trying to, if health is doing this over time, right, this is where you intervene. You may be trying to slow it down to the point that you get here instead of here because this is worse than this. Right? We want to stop maturation because age is declining or health is declining with age. Could go up or down. It depends on the issue. Certain things are going to be maturation because they happen over time. Right? People are going to make more money over the course of their life. Just generally, people get more work experience. They're in their job longer. They get raises, right? So sometimes that's a maturation issue. Education's the big one. Right? Things like that are going to be things that you have to deal with as a threat. Questions about any of those 4? Are there no questions, or is everybody just asleep, or can nobody hear me? I'm talking to myself. If you can still hear me, put something in the chat box just so I know. We're good. Okay. You can still hear me. It's obviously just really boring. That's fine. I'll keep going. Okay. Regression to the mean. This is one of my favorite ones to talk about because I get to use a sports analogy. All right. We're going to go back to the same model here, right? This is, we're going to call this a football season. Anybody knows there are week 0, week 16, it's about week 8, week 4, this is week 12, something like that, right? Quality/performance, right? Let's go ahead and say we're talking about, we're going to, let's look at who's a team that's really bad this season. That sucks. I don't want to knock on the Browns anymore because they're actually getting better. Let's talk about the Jaguars, right? Jacksonville Jaguars, not necessarily one of the better football teams, right? We expect an average level of performance from the Jacksonville Jaguars, right? So let's say, right, this is a quality scale, right? We'll say the Patriots are up here, as much as I hate to say that, right? The Rams, right? Your Browns are kind of about here, right? This is kind of a talent scale. Who else was really terrible? Like 49ers, they were bad, something like that, right? And we're going to, this is our scale that we're using. We're going to track, right, the Browns, right? And they're basically here, week 1, right, week 2, right, week 3, right, week 4, right? Let's say, right, something like this, right? So they're, right, they're a little better, they're a little worse, they're a little better, a little worse, right? They fire their coach, they get a new assistant coach who takes over, right? They do well for 1 week, they drop, right? Then they have an amazing game, they hire a new head coach, they're super motivated, they beat the Patriots, right? The next week, they go back to being terrible, right? Something like this, right? This is how we plot the quality of the team over the course of the season. Now, if you were to take all these numbers and you were to come up with their average performance, right? What you would get is basically something like this, right? Where we would say the average, right, or the mean performance for the Jaguars is about this level here, right? But on any given Sunday, as we like to say, something can go crazy where they stand out, right? And they happen to have a home game on a short week. The Patriots are tired, coming off a bye week, whatever it happens to be. They beat a team that's much, much better than them, right? Regression to the mean is the idea of this, right? If we only start tracking the Jaguars' performance right here, and we say, well, right, they are very, very good, right? Let's see what happens if we implement this new training program, right? And then we collect our next week's data and we get to right here and we say, wow, right, they really did terrible. That training program is not something we want to continue, right? Or if we continue to track data, we say, man, they're really bad, right? What happens right here, right, where we drop back off down to, right, this line is a regression, right, a reversion back to the mean, right? They revert back to the average level of talent, right? So what we would call statistical noise, right, there's going to be some fluctuation like this, right, over time. They're going to have better weeks and worse weeks, right? But there is an average level of performance that is, right, this line right here. Because that is their mean or average level of performance, the logical expectation is that with enough time, they will revert back or regress back to that average, which means anytime that you pick off of an extreme value of something, right, you are potentially at risk of a regression to the mean threat, right? So where is this example in program implementation? Very common case. If you have a bunch of students who have very bad test scores, and you take all the students with the worst test scores and you put them in a mandatory program to help them with school because they are the worst performing, right? Guess what happens? Well, let's just say some of them happen to have a day where they're tired and they didn't, right? They didn't sleep the night before and they're hungry and they're having issues at home and what have you. And then there was a big test. And then that day they had a really bad, right, test score and their performance was here. And this is when you pick them up and you enroll them in the program. And guess what happens? Is shortly afterwards, their performance shoots up right? And then then their performance looks like this the rest of the time, and you say, look how good our program is because of this, right, change right here, right? You pick them at one of their lowest points, one of their worst days, and they probably, right, regress right back to their average level of performance. The fact they got put in your program because they had a poor score at a certain point in time, but were not a poor student, right? They just got picked up at an outlier, right, level, means that the logical expectation should have been that they go revert back and regress back to whatever rough average level of performance they would have been at otherwise. Right? This is regression to the mean. Right? The people who are the worst health, right, or the worst wellness and nutrition, or the worst performers, or the most in need of employment assistance, whatever, right? You're grabbing them at the worst point in time for them, and they're probably going to have some level of getting back to wherever they were, whether you do anything or not. It's kind of like maturation, but it's not really the fault of the time progression that leads to it. It's just the fact that you pick them at an extreme, and that they're going to go back to the non-extreme level at a certain point in time. So right, getting extra data, because let's say, let's go back to the student, for example. Right? If we picked them here, and then they shot up, and then we see this, right? And we say, well, look, our program, right, led to the difference between all of this point and this period, and so we had an impact. Right? If we'd have collected a little bit of data beforehand and we saw this, right, we would have said, this is not actually the normal performance of the student. This is an outlier, and their average performance would have been here in the first place, and we just picked them up, right, at a bad choice. Right? That's again how we deal with this threat, by saying, well, if we collect a little bit more information, we can monitor the pattern and see the fact that, right, they had an average that was going to be around here in the first place. Right? It's very possible that, right, we see something like this. Right? They drop, right? Then they shoot up here, and we see this. Right? Their average should have been this. Yes, we picked them at a bad spot, but look, clearly we led to a positive impact. That is the net result, right? This is the regression to the mean impact, right? But this is the program impact, right, which adds to it, because look how well they stayed at even a better performance level in the first place. That make sense? Questions about that one? Okay, attrition. Right. The key thing to remember here is this word, systematic attrition. If you have a sample of 1,000 participants and you're trying to track them over a 12-month period, no matter what you do, you're going to lose some of them who don't participate in your study, right? That is just general attrition, right? Attrition does not equal, right, systematic attrition, right? Really, the key to remember here is, if you're going to lose people, right, think about what we're trying to do is, right, we're looking at the average, right? Let's say we have 50 people in a nutrition program, right? And this is the average, right? We'll call this weight. Right? Everybody's in the program. This is how much they weigh, right? They start the program 3 months later, right? This is the average weight, right? Now we're trying to say that, look, our program led to all this weight loss, right? If all of, let's say, the most out of shape people in the program, right? The people who are either the most obese, the most overweight, the most out of shape, quit 2 weeks into the program because it's too hard, they don't want to do it, and leave my study, right? So everybody else stays but the worst. Right? Guess what happens to your average when that occurs? Right? If we'd have measured everybody again, except for, right, our, let's say, most out of shape 5%, we might have had this level of weight instead of this level of weight, right? Well, look what the difference is here. Right? This is the same value as the one that we found at week 3, right? And it had nothing to do with our program. It's because we lost the people who were compounding and creating this difference in weight, right? Remember, if you have an average, right, let's say the average, right, we have our average weight is this amount, right? Some people are going to weigh this amount, some are going to weigh this amount, some are going to weigh here, some are going to weigh there. Right? Everybody's going to have a different amount, but this is our average. Right? If we lose this person and this person, right, it won't have an impact really on shifting our average, right? But if our average is this, and we have, right, people with these weights and people with these weights, and we lose these people, right, from our study, right, our average shifts, right, down to this point. And now the loss, the systematic loss of those people at the high end of the range is what resulted in that shift, not because anybody actually lost weight. Right? So this matters when you think about test scores. High performers or low performers are lost. They're going to shift the average. Right? Nutrition, if you're looking at like healthcare programs, the sickest or the most healthy are the ones that lose. Right? They're going to shift the severity of a condition score. Any of those type of things, if and only if you lose people at one of the two extremes, or is your average going to slide the opposite direction of the loss. So, right, if you lose some of your best and some of your worst, and both sides, really doesn't matter because the average should stay about the same. Right? It might change the number, but it's going to move a little up when you lose these people, and it's going to move a little back down. Right? It's going to stay in a similar range. But when you lose a set group of people from one end of the spectrum, your number's going to change, and that's a problem. Questions about that one? So testing, right? Testing is pretty easy to think about. Testing, the idea is that, right, when we think about a test, what we're talking about is a measurement tool. So in some simple cases, what we actually specifically mean is a test like an examination. So let's say we're dealing with elementary school kids, and we're looking at a program that's meant to improve, say, math scores, for example. If we're testing math ability every 2 months for 2 years, right, and we use a math test that's like 25 questions, multiple choice, we never change the test whatsoever, right? They're going to see that math question so many times that they're going to do better on that test just out of pure experience of having done it over and over and over again every single time and knowing what the questions are going to be, that they potentially will start to get better scores either from experience, from learning, because they know what the questions are going to be, and so they study for the test next time around, not because they're learning any more math, but because they just happen to know the questions. Right? That is a testing effect. The net increase that you see in scores is because the fact you never changed the questions, people knew what the expectation was going to be, right? And then as a result, they get more experienced, right? And then you're confusing the impact on math scores with just exposure to the test too many times. Right? Instrumentation, right? This can basically be the idea that if you change your measurement strategy, right? Instrumentation is the idea that and this is why you have to basically plan your measurement strategy up front and stick with it. Because if I change the way I measure things halfway through my research, right, it is no longer consistent from point 1 to point 2. And I can no longer tell that if you were a 55 on a depression scale before, and I used a new depression scale, whether you would still be a 55 because the reliability issue has now been brought to light. Right? You might be a 55 and you should be a 55 now because you didn't get any more or less depressed. But because you're a 55 on this scale, now you're a 51 or a 42 or a 38, right? Because of the fact that we changed the measurement, not because you're any better or worse off than you were. Right? That is now an instrumentation threat because the change has to do with the fact I tinkered with measurement, not because you actually improved. Right? The same is true of if we look at, let's say we have we'll go ahead and say we're looking at, we have depression again, right? We have a 60-point scale, and let's say we're calling severely depressed 50, right? Anybody who's in this range here, right, we're going to say is severely depressed. If for some reason you decide right? The measurement system stays the same, but later you decided that, well, 40 actually makes more sense, right, to be considered severely depressed. Actually, let's take that back. Let's say you decided to mark 55, right? What used to be, right, this range of persons, right, that would have been considered severely are now, right, this range of severely, right? And what happens? Well, because you changed your cutoff and because you basically made the threshold smaller, right, less people are likely to end up in there, whether or not they actually are improving in their condition, their symptoms. Right? They may not be getting any less severe at all, or less people have depression than before. Right? It's just the fact that anybody who fell in this range, right, now got classified differently because of the decision that you made, and as a result, right, didn't get counted as severely depressed. And so you would say, look, we had a 12% decrease in number of severely depressed persons because of our program, right? Well, maybe this was 6% and this was 6%, and the loss was basically just because you classified differently and cut these people out and are only left with 6%, right? That is where instrumentation also becomes a problem. One other issue that's not on here, but I'll add, is the Hawthorne effect. Does anybody remember the Hawthorne effect? Typically, if you are, I think they usually teach us an Ord theory, PPA, I'm going to say 660 maybe, Ord theory and behavior. Right? The Hawthorne experiments were these experiments where people came into a business, wanted to study productivity, and so what they did was they basically put a bunch of people in a room. They were doing manufacturing experiments, and then they brought the amount of light in the room down a little bit, and then the people got more productive. And then later they turned the lights down even more, and they got more productive. And then they turned the lights down again, and then they got more productive. And this kept happening to the point that basically all the employees were basically working in the dark and were the most productive that they've ever basically been. Right? The conclusion here is not that, well, changing the lights and making it darker and harder to see results in more productivity. What actually happened was that because the people were being researched and studied and engaged by their supervisors and in a project, right? If you're being watched less, yeah, you produce less. I mean, that could be it, right? It could have been some of that, which is I'm in the dark, and now, right, no one knows that I'm not like doing anything, and so I'm being better off. Right? But the idea was that, well, it was purely the fact that these people are being observed, right, and being engaged and being part of something in the workplace meant that they wanted to do better and better and better because they were participating in this study. Right? This is something that it's, I mean, really probably falls under testing more than anything, or instrumentation. It's kind of somewhere in between, right? But if you get to the point that, right, you're starting to see results, the fact that we tell you that we're doing a nutrition study and we're trying to evaluate the effect of this program, we'd really like you to participate, right? People may start to try real hard and really want to have an impact because they want to show that this program is working, right? They like this program. They know it helps, right? Because they're in a study, their behavior changes, what have you. Right? It's kind of selection bias. It's kind of a measurement problem. It's somewhere in that middle, but it is something to also be concerned with, and it's a thing that needs to be considered. And this last part, well, there's no good answer to, but any combination of these can work to make another one even worse, or it could be some combination of these, and it may be multiple of these or an interaction of multiple that are potentially threats. I mean, I hate to say it, but there's really no way of knowing that for sure, right? But as long as you think through all these things, you've done at least a pretty decent job of being able to start your way down a path of being able to address major threats that are potentially a concern. So there are questions about any of those threats to internal validity, the differences between them, how they apply to your programs, any of that type of stuff. All right, let's keep chugging along so we can get through this one. So designs. I've talked about this a lot already, so we'll try to move a little bit faster through this, right? But really the point of this whole section is the idea that how you choose to design your research. And by design, right, we're going to talk about X's and O's, right? An X, right? This is the simple way to think about this, right? The X is when the program started, right? The O's are when data is collected. Right? And this is, right, every time, right, the data is collected. And so you'll typically only have one of these, and you'll have multiple of these, right? And think about this as just a really simple thought experiment where I know I'm going to collect data. I know my study is going to take place over a certain amount of time. I need to figure out how long it's going to take place over time, right? So that I can design, right, something like this that I was drawing before, which is, well, how many points of data do I need to get the pattern right to address the major threats, right? And so if I'm going to put this on paper, I need to be able to I want to jot this out because I can't go back afterwards. So I want to make sure I get it right the first time. So what we have here is, right, considerations, right? When you're mapping it out, there's always practical logistical. I can't do a 15-year-long study if I don't have the money nor the staff to follow people for 15 years, or nobody's going to pay me to do it, right? Ethical considerations, right? As much as I would like to be able to have a control group where I tell people, sure, we'll give you welfare benefits, but you can't have them right now. You need to sit for 6 months in your current poverty status and wait for us to give it to you because we're going to do some research and you need to hold off, right? Not a decision we can make, right? Stakeholder, if I happen to be doing research for the Department of Public Health in San Bernardino, I don't just get to study anything and everything I want. Sometimes I get to if I can make a case to my boss. But a lot of times, right, we have grants, we have the state, we have the federal government, CDC give us money. There are particular things that money is meant to be used for, and therefore there are particular things we need to focus on, right? If we get a grant to try to address syphilis cases in the county, right, I can maybe look at STDs, but really I have to spend the majority of my time concerned with syphilis because that's what the money is for, and that's what the state wants to know that we are spending it on, right? We've talked about the X and the O, right? If you think about a couple other things, right? So each line, right? This is a new group of persons, right? So if you think about X's and O's framework, right, we might say, I'm going to collect data, I'm going to implement the program, and then I'm going to collect data again. This is from the treatment group, so the people who are in our program, right? This is line 1, right? We also will have line 2 where we have a group of people who are not participating. We collect data from them at the beginning, then we also collect data from them a second time, right? We could put a line here if we want to where they, the absence of the X is the basic idea that they did not get the program, right? So the second line is the new group. If I get to randomly assign and say, I have 100 people on a wait list, we can only help 50 at a time before the next, right, 50 could join the program. I might get to pick half of these people who get to participate now and half that have to pick it later, right? This is when I get to add the R and say this is the random assignment, meaning, right, coin toss, you get put in one group or the other. So not all the time is this an option, but if you have the ability to control who gets put into the group that gets to participate or the group that doesn't, then you might have random assignment. Right? So the drug trials where people get to do the placebo and choose who gets the placebo, things like that. That's where the randomization comes into play. No control group designs, right? If I have, right, nobody to compare to, I have people who, right, they weigh in, right, they participate in our program, and then they weigh in again, and I say, look, over time, people lost weight, therefore our program works, right? We're not comparing to anybody else at all, right? This is what we would call sort of a non-experimental approach, right? This is what we would tend to call, it's not random, right? We don't have the R's, right, to say, well, we got to pick people to put them into two groups, right? And there's no counterfactual, right? We don't have a comparison group to say, well, what would have happened if the program wasn't in existence, right? Because that's not there to compare to, right? This would be our counterfactual, right? Counterfactual. The group that would have been what would have happened if we didn't have a program, right? This becomes the sort of weakest design of them, right? And what you'll see here is that there's a number of different types. I'll cover just a few of these so you can kind of get the idea, right? If our program starts, right, in May, and the program kicks off and it's a month-long program, and then June 1st, right, we weigh everybody and we say, well, what is your weight? Right? And we say the average weight is 152 pounds, right? This is basically a one group post-test only, right? If it happens after the X, it's a post-test. If it happens before, it's a pre-test, right? Because there is only one after the fact, it's a post-test only, right? This is basically the worst type of model that you can come up with because you don't even have the comparison to before the program started to say, did it go up or down from there? You're basically just saying, well, I showed up. I was required to evaluate this program. It already started. There was no data from before it started. And so I'm just going to say, well, their average weight is now this. I think that's good. Maybe it's not. I don't know, but that's what it is, right? One group pre-test, post-test design. Right? I weighed everybody on the first day of the program before they got to do anything. Right? They spent 30 days in our program, right? Exercising, nutrition, learning from us, etc. I weighed them again, and I want to see if their weight, right? Here's the program, right? Does their weight go down during that period of time, right? This is your O, this is your X, this is your O, right? Remember, this is their weight. So I'm going to try to draw these out a little bit too, so hopefully that helps you kind of visualize because sometimes the X's and O's don't make any sense. This here, right? One group, so we do two pre-tests before the program kicks in, and the third. If we're looking at something like this, we're looking for this pattern, which is right. Our program kicks in here, right? This is option one, observation one. This is observation two, right? And then this is, let's say this is their weight. Right? This is observation three, right? So we have, right, our X is here, right? So we have our O1, our O2, our X, and our O3, right? Well, what happens here? Right? What we're basically looking at is, right, there was a trend of weight loss, right? People signed up because they are interested in getting healthier, right? We sat around for a couple of weeks and watched what happened to them before the program started, and we saw there was a decline, right? There was, we call it maturation, we call it whatever we want, but basically there was a trend already happening, right? Because we waited, we knew what that trend was, and then we implemented our program here, collected data a third time, right? If the trend would have continued, we should have saw something that continued on that same path, and they should have been weighing in at this level, right? And I guess actually it should have been more like this level because this is where we actually are now collecting our data, right? But what we actually see is this steeper line, and so now their weight loss is even lower, right? And so what we can say is, well, there was a downward trend, but our program still had this impact, right? And if we hadn't have collected this first pretest data, we really wouldn't have been able to know that. We only know that because we added, right, the extra pretest onto our research design. This repeated treatment design. So this idea, again, this is where you have an O, an X, an O, a removed X, and an O. Right. Again, this comes back down to pattern matching. So if you think about where we have people who have a condition, right? Let's say they're this level of, right, this is, we'll call this medical condition, right? Where they're at this level, right? We start a drug treatment process. We give them the actual drug, right? We see a decrease, right? They get to this level, right? Then what actually happens is we implement a placebo, right? So this is actually the removal. So X is the actual drug, right? And then after a while, what we do is we put them on a placebo without telling them, right? Because then what do we want to see? We want to collect data again, and we can say, okay, we put them on the placebo, their condition got worse again, right? So because we collected data here and here and here, and during this period of time, right, we know that they were on the drug. Right? And in this period of time, we removed them from the drug and gave them a placebo. Right? We saw that the pattern changed between this point to this point to this point, that we were controlling that because of the fact that we were using, right, the real drug and then the placebo. Right? And you can add to this if you wanted to do this again and say, okay, well here, right, we give them the drug again, and then we take data again, and what happens? Right? If there's a selection bias threat, if there's a history threat, whatever it happens to be, remember, it has to now make the same case that at week, we'll call this week 2, week 4, week 6, and week 8, right? That every single one of these same changes in direction happened at these exact same times for us to be able to legitimately believe that whatever else you're talking about is the same threat that resulted in the same impact that our program, drug treatment, whatever has. It's very likely the more those points and the more you're able to manipulate that data, that's a threat that's going to hold up, right? Because the FDA is working on a new drug. There's clinical trials at the federal level, but they all happen to start and stop and start and stop again during the same 8-week period that you're doing your drug trial. Very unlikely. Right. This example here, this is the idea of counterfactuals, right? The reason that we have a control group, why do we compare to another group of persons, right? In a perfect, right? I'm going to call this, and so we're going to call this city manager, right? We have a city manager, right? This is city 1, right? City 2. Right? So we got 7 different cities, right? City 1, city 2, city 3, city 4, city 5, and 6, and 7, right? Different city managers. We want to know if women spend more on, let's put that, well, yeah. Let's say women spend more on social services in the city than male city managers, right? We believe our hypothesis is that women are more caring, they're more nurturing, they're more willing to allocate more of the budget to social services than men, right? In order for us to know exactly if that's true, right? For city number 1, we'd want to know how much a male city manager spends on social services, let's say $10 million in that city. We'd also want to know if a female city manager running the same exact city what she would spend, and let's say she spends $15 million, right? If that were possible, we would know that 5 is the difference in city 1 for the difference between a male and a female, right? And in city 2, we might have the same result, so we have a $0 million difference, and then we might have the difference between 20 and 30 and a $10 million, right? And so each of these cities, we could say, okay, city manager, you're now fired. We're going to instill a woman female city manager, a woman city manager, see what they do with your budget, right? And we're going to fire the next one, and just change them out, right? We'd be able to look at this and we'd be able to see that the average was a $5 million difference between male city managers and female city managers, and we'd be able to say, female city managers do in fact spend more on social services. This is how it's going to work in real life, right? We have, again, our cities 1 through 7, right? City 1 and 7 have female city managers. Cities 2, 3, 4, 5, and 6, unfortunately, all have male city managers, right? And we don't really know what would have happened here, or here, or here, or here, or here, or here, or here. We only know the instances where we have data where there's a woman or a male only in the one city, right? And so we don't know any of this information. Right? What we do know is that, well, if we take the average of these values, we get 16. If we get the average of these values, we get 22. Right? So what we do is we estimate, we say, right, well, the impact of being a female city manager is about a $0.65 million increase in spending on social services when compared to men, when in actuality it should have been 5, but we overestimated because we don't actually have the perfect data. Right? This is how control groups work, right? Because we don't have all this information, we have to try to budget, or not budget, sorry, we have to ballpark what this number is from differences. And what you can see is the numbers aren't the same, right? They're off. And we overestimated some because of the fact that we don't have the same one city getting 2 different city managers coming up with that data, right? But we have to estimate because the alternative is we only know this number and we don't know any of this. And we just can't answer our research question. Or we just basically are left with no frame of reference whatsoever, other than to say, well, men spend 16 million on average on social services. I guess that's maybe more than women. I don't know what women would spend, but that seems lower, higher. Right? You don't have a frame of reference to work from. Right. Experimental design. I've talked about this before. Right. This is obviously random. So you have a big pool of people who want to participate. Right. I'll do it this way. Right. What generally happens is, this is like the population. So let's say this is everybody in the United States that has kidney disease, right? There's a whole lot of them, right? Only a subset, right, sign up to be in our study, right? So we have our study sample of, we'll call this kidney disease, right? We don't get everybody. We get those people who sign up and actually want to participate in our study, right? We have the treatment group where we basically have the drug, and then we have the placebo, or we call this control group, right? This is the placebo, right? If people got to choose which of these two boxes they go into, right, we would not have random assignment because they'd have selection bias because they say, well, I'd like to try the drug. And the other people would say, like, no, thank you, right? And the people who want to try the drug may be different because that's why they signed up, right? So what happens is we go through, right, we'll call this a randomizer, right? We basically say, you don't get to know, we're just going to put you in one of the two groups, right? And some of you are going to go here, and then half of you are going to go here, and you're not going to know until the trial is over because we want to make sure that the two groups are about even by randomly putting people into two groups. And by doing that, we should basically be able to say that, right, we should have about the same amount of, right, roughly men to women, right, in both of these, right? We should have, roughly average ages because we split everybody evenly, right? Our racial groups, right, should, if randomization in theory works like it should, right, all of the differences between the two groups should balance out, right? Because everybody has an equal chance of going into the two different groups. And that includes all of the non-physical, non-obvious characteristics like, how bad their condition is, how motivated they are to get healthy, all those other factors that may come into account should also even out because some unhealthy will be in one and some unhealthy will be in the other. Some motivated will be in one and some motivated will be in the other, right? And that's where the randomization comes in. And so this is where we'd say, okay, well, you're randomly assigned, right? You're randomly assigned and you're randomly assigned to either the group that is pre-tested, gets the drug, and is post-tested, or the group that is pre-tested, doesn't get the drug, gets a placebo, and is post-tested again, right? That's basically the traditional experiment, or what we would call a randomized experiment, or an experimental design where people have control over who gets what, right? In the drug case, right, this might be the person. So we randomly assign the person. Doesn't have to always be the person, right? If you read the evaluation article that's on the Progressa Social Services program that was evaluated in Mexico, they actually use a countrywide social welfare program and randomly assign different villages in the country to get the social services. Like basically, if we could say that Social Security is going to get rolled out in Omaha and Minneapolis and New York, but not San Diego and not New Orleans, and not, right, Muskogee, Oklahoma, right, and control it in that way. They basically do that, right? And so it could be the person, so it could be the student, whatever, right? We may pick schools within a district in certain classes. Certain schools are going to be randomly assigned a new training program and others are not, right? It could be the classroom, right? Could be the neighborhood, could be cities, right? Doesn't really matter what your unit of measurement is, right? But you might randomly choose, we've got 50 schools in our district, 25 are going to start this program initially, and 25 are going to get it later. We're going to have classrooms, and 5 teachers are going to go to this training, and 5 are not. We're going to randomly pick which ones. Okay, so you might use this in a number of different contexts of varying scale, right? But you still potentially can randomize certain things depending on how you think about that, right? We're going to put in a neighborhood watch program. We've got 8 cities or 8 neighborhoods in our city that are very high crime. We're going to randomly implement 4 of them to have this neighborhood watch program first, because we only have so much resources and time to get off the ground. So we're going to pick 4 at random. Well, the other 4 are going to wait, and then we're going to look at crime in those 4 locations compared to the other 4 until we 6 months later get them the neighborhood watch program. Right? That might be another way of random assignment. Right? Why can't we always randomly assign? Well, there's a number of different reasons. It's not always practical, right? For example, there are, right, a lot of times where you're going to come into a program as an evaluator, for example. Me, as the research manager, I come in, right? Most of the programs in public health already have started. They've been up and running for years. I just came into the picture. I can't randomly start telling people like, this is a new program, you're not going to get it. Everybody's there. There's either no pretest data or they basically are collecting something in some way, and that's all that's available. And I can't start turning away new people and saying, nope, sorry, you don't get the service, right? So sometimes you just come into a situation where it's not the option, right? This is the biggest concern, which is the ethical, legal, practical considerations. Right? I would love to be able to say, okay, we're going to do a WIC study. We want to really look at the impacts of women who use formula versus choose to naturally breastfeed, right? Except we're going to require, half of our mothers at not their discretion to basically be forced to formula only feed, and another half are going to have to only use breast milk, and we're not going to give them any benefits, and we're not going to give them any other options. They just have to do it that way because for our research purposes. It's not ethical. It's not something we can do. People have that freedom to choose the way that they want to raise their children, to choose how they're going to implement, right, the nutrition of their child, any of those type of things, right? There's legal reasons. People who are eligible for benefits have to meet a federal law or statute. If they don't earn enough money below a certain amount, they become eligible for benefits. We can't turn them away just because of the fact that we want to do a research study, right? Another example here, right? We can't force half of mothers randomly to have to spank their children while the other half are told not to, right? I mean, you could see a number of examples where this doesn't make any sense. So what we call quasi-experimental, basically any of those that I showed you, right? This version, right? This version, right? Anything like this. Any of these where you don't have, right, the random part in the beginning is what we call quasi-experimental. Right? It's kind of similar to an experimental design, but because we didn't do the random assignment, it is not a true experimental design. It is a quasi. Right? So this no random assignment into the two different groups is what makes that specifically, right, a quasi-experimental design. Right? What does that mean? Selection bias, the ever-present problem, right, is always going to be there because we didn't get to randomly assign. And because we didn't randomly assign, we can't know for certain two groups that we are studying are on average equal, and that any type of selection issues balance out between the two groups because these people got to choose their way in, and then these people were just asked to participate because we needed a control group. We didn't get to force who went into those two groups. And that's what always is going to produce this in the first place. Right. When we add the control group, right, another way of putting that on paper is this, right? So this is non-random as opposed to random. Right. And what you basically see here is things that are very similar to the X's and O's that we saw before, except in this case, we have a group that is participating in our nutrition program. Let's say they weigh in, right? Then they go through our health and wellness program. Then they weigh in again, right? We have a different group that weighs in, does not participate whatsoever, and we weigh them again because we want to compare, right, the trend over time of group A, right, to this control group, right, trend of group B. Right? We're still measuring the same outcome. We're still looking at the total weight or their BMI or whatever it happens to be, right? But now we're comparing, right, what we call the treatment group, the people who, right, got the X, right, to the control group, the people who, I'll say O, right, we'll call this the no X people, right, basically, right? So that's the difference here, right? You'll see this, right? This looks exactly like what we had before, which is the first O, the second O, then the treatment, and the third O. Again, all we did was simply add, right, the control group to compare to see if, right, the same thing or something different is happening amongst a different population of people who are not participating, right? So the absence of, right, the X tends to be the big issue that we're dealing with. Right. Here we have something a little bit different where, right, let's say, for example, we measure people's disease prevalence. Right. This group gets a drug right? Whereas this group, right, gets a placebo. We measure them again, right? The initial group we stop giving the drug to, they now start getting the placebo, right? This group now gets the drug. We measure them a third time, right? So the same way that we want the first group, right, to see their condition get better, right, and then maybe get worse because they're on a placebo, right? The other group we should see, right, basically no change, right? Then they get the drug, right, and then they come off the placebo, right? So we basically would see, right, the first group gets the X here, right? The second group gets the X here. I think that's right. Right, but the idea is that we take the actual drug away from one group and swap it, and so we see if we start to see the same pattern happen for the second group as we take it away from the first group. Right, so each group is both serving as a treatment and a control at one point, depending on where they are in the process. Right, which you'll see here, this has got a plus sign, this has got a minus sign. Typically, you won't ever see something where you give, right, and then you take away from another group. But what we'll call this kind of like we call this exposure to treatment, right? So a really good example of something like this would be, not really good, but a good example. If you have a job training program, right, and you basically have, right, there's a 4-hour workshop that some people get, right? There's a 4-hour workshop plus an 8-hour coaching session, right? And then we have the 4-hour workshop plus the 8-hour coaching session, right? Plus a, I don't know, we'll give you like a jobs database access, right? And you can either have one, or you can have two, or you can have three, but you don't have all three of them, right? We might have a group where we look at job placement that gets, right, package, we'll call this X1 treated. We have another group that gets X2 treated, and we get another group that gets X3 treated. Right? And these folks get the 4-hour training program. These folks get the 4-hour plus the coaching, right? And these folks get the 4-hour plus the 8 hours of coaching plus the jobs database access. Right? What we're looking to do is see if the net impact of giving different services and greater packages of support have better outcomes. Right? So if we're looking at how quickly they get a job, right, is the average amount of time 70 days here and 30 days here and 12 days here. If you get a job in 12 days, kudos. Right? That's impressive, right? But the idea is we're looking at, is there an impact of giving more services? Right? We're not comparing to anybody who's not getting a job. We're just comparing that if we vary the services we provide at different magnitudes, is there an impact? Right? If this group is 70 and this, right, is 70, then access to the jobs database is not something that's making a difference, right? Or sorry, the 8-hour coaching call is not making a difference because it's still 70 for group 1 and 70 for group 2, right? So maybe we can cut back and say, well, the coaching call doesn't matter, right? Or at least from what we can tell right now, that the extra coaching hours are not doing anything we can tell of actual extra consequence to anybody in the group. Right? The big thing is thinking about what you expect. Right? I recommend that for most of your own purposes, and I won't really require this in the discussion post or anything like that, right? Always just go back to this, right? Think about time, right? Think about outcome, because this is basically how you're thinking about this, right? At some point, you're going to have, right, a program that starts, right? You always are going to have your X, and you're going to have, right, something that maybe looks like this, right? And this is going to be your treatment group. And then you're going to have something like this, which is going to be, right, your control group, right? And maybe you have, right, 1, 2, 3, 4, 5, 6, right? So you say that this is a 5 point, right? And then, right, 5 more, something like this, right? And then I take my red group, and then I have the same 5, right? But then they get the X. Right, and they also have 5, right? So this is really all you're doing, mapping this out and trying to basically come up with what is the pattern I should see, right? If our control group in this example is, right, the blue group, and this is a nutrition program, right? If this is where the nutrition program starts and we're looking at, right, body mass index as the outcome, then I would expect to see this decrease as a result of our program, and I would expect to see this lack of change here, in the control group because, well, we're not helping them, we shouldn't see any different change if our program is leading to the same impact. So I think it's a worthwhile exercise to help you with this, which is, right, you can figure out every point, right, is an O, and it's every point that you're going to collect data. Whether it doesn't have to be, 1 O can be a month, 1 O can be a year, 1 O can be, 24 months. It could be every hour. It could be, right, every 6 hours. Doesn't matter, right? But the key is to sketch out what you would expect and what you expect from your control group, and think about those different threats to internal validity as well, and what they might do to this same pattern, because that'll help you figure out what you should expect to see, right? Should they grow apart in the same direction? Should the control group not change? Right? Should the control group go up, right, while the treatment group should go down? Right? If I do multiple pre-tests, should I see a rising trend or a decreasing trend or an even trend over time? Right? Should, right, we see a drop, and should the drop start to come back up again the longer it is, right? You can think about, for example, if you have a program that does, right, nutrition again, we should see a decrease during the length of our program. Our X is here. Right? We may either see them continue to hold the weight off, or we might start to see this again, where eventually they come back to where they were, right? Which means if I can start them in the program again and see them drop back off before they come back up, right, maybe our program needs to be continually implemented in order to be able to have a continued impact, right? And if you're somebody who works for government who wants money for your program and can show that this is happening, what a better way of saying, look, our program does work every time we implement it, and if you stop giving us money, right, they're going to come right back to where they were, so we should be able to continue working with them as long as we possibly can, because their health or whatever is going to stay better longer. Time series designs, we talked about this before, right? Time series design, the trash example, right? The only thing that makes it time series is the fact that there's just a whole lot of O's, right? There is no clear answer for how many of these are, right? This could be, right, as we looked at in the trash example, this was every day. Each O was 1 day for 6 months, and they did 6 months this way, the same direction, right? So it was a whole lot of these. Right? We could still have this remove treatment example where, right, we have the treatment here, and then we take the treatment away, right? So we have 6 months, we implement our new trash program, 6 more months, we stop the trash program, we see if everything goes back to the way it was, right? Something like that. These tend to be more common if we do like large-scale interventions where we're looking at citywide policy or neighborhood-wise policy, something that when we're doing policy analysis, we have to look at 6 months of time, and we're looking at a lot of fluctuation and a lot of data, and a very clear break point where we can say, right, this is exactly where we started this new program. What happens afterwards? In this example, most of you will probably not use this at all, but it's interesting to talk about, and it's called a regression discontinuity design. And really, I think a good example is to show you this, right? If you have a clear breakpoint, right, in an example where this is where, right, this is looking at drinking behavior, right? And how many people have 12 or more drinks in a year, 12 or more drinks in their lifetime, or 12 or more drinks in their, 12 or they have some heavy drinking, right? So this is heavy drinking. This is 12 or more drinks in a year, and this is 12 or more drinks in a lifetime, right? If you have a clear breakpoint, and we know that legal drinking age is 21 years old, right? What you can do is you can plot, right, the lines for each of these different trends and say, okay, if we know that there's a clear and obvious breakpoint, right, what happens to the trend before and after that, right? And what you'll start to see is, right, there is a difference where the trends split in many instances because, right, as people start to get closer and closer to 21, right, when they're legally allowed to drink, we see a big shift in the number of, so what is this? This is the squares, the proportion of days that they're drinking, right? So how many days they drink, right, it starts to increase to the point that when they hit 21, there's a jump at 21 years of age where people drink more frequently, right, until it slowly starts to work its way back down, because as people get older and mature, right, they stop drinking as much. Right. So it's an interesting technique. It really only works when you have a very clear and obvious breakpoint. So if you have, for example, let's say this is like test scores, right? Maybe, and you know that there are people who, if they're over a test score of 80, they get put, let's say under 80, they get put in a particular training support program. If they're over that, they don't, or something like that. This works as a model that can be used. It's kind of like a time series type of a structure, but has very specific use cases. So we're not going to worry about that. But I want to pull up your assignment for next week in terms of your discussion post, so you can get a look at that, just to make sure everybody knows what they're going to be doing. So let me pull that up real quick so you can see it, and then we'll see if there's any questions. If you have any questions about any of that content while I'm pulling this up, go ahead and throw them out. If you have individual questions, I'm going to stick around after I close out this lecture in a couple of minutes. I'll field individual questions. So don't worry about that. Let's get your discussions. Hopefully you got a chance to sneak in your measurement ones if you didn't have those done by the time the class started. And so then this will be your next one. So you're going to develop one X's and O's framework to go with one of your research questions. So presumably the one that you picked as the outcome that you're going to measure in your measurement post. Choose that research question. You don't have to, but choose one of them, right? Come up with an X's and O's framework, right? So it could be as simple as pretest, treatment, post-test, control group, pretest, post-test only. Right. For that one, explain, or for that research question, explain what threats to internal validity are of concern for your results. So I guess I should probably share this since you're not seeing it. Right. So you're going to basically be able to explain internal threats to validity. So there are not going to be all of them. Don't try to go through every one of them. And remember, if the threat is likely to have the opposite impact, so if it's something that would lead to like an increase in obesity, not a reduction, it's not a threat, right? But if you have, let's say, selection bias and history and outside effects are threats, just give me a very basic synopsis of like why you think that is a threat to internal validity for your evaluation. Right. And then for the control group, right, identify very basically who might serve as a potential control group for you to compare to, and then address just the basic question of, are you able to randomly assign or not? Right. In many cases, it's going to be no, ethically, legally, whatever. There's not the ability to do that. But think about that and figure out if it is possible or not. So can you randomly assign? And if so, what would you assign to? And then if you're going to have a control group, who might that control group be to compare your results to? So are there any final questions about the post for next week, or anything about the topic in general? Or final questions about the lit review as well that'll be due in 2 weeks? Okay. If there's no other questions, I'm going to go ahead and close out the recording. I'll stick around for individual questions, basically for the next 15 or 20 minutes or so, depending on who needs help. And otherwise, I will see you all next week. Have a good night.